Natalie is making cookies that contain both peanut butter chips and chocolate chips. I smell a system of equations coming up. She used a total of 16 ounces of chips. A total of 16 ounces of chips. So that's going to be the result of one of our equations. So a 16 ounces. There are 8 chocolate chips in each ounce of chocolate chips and 12 peanut butter chips in each ounce of peanut butter chips. If Natalie used a total of 300 chips, okay, so 300 chips is going to be the other total in her cookies. Write a system that can be used to find the number of ounces of chocolate chips and the number of ounces of peanut butter chips she used. So we're just going to set up the system. We don't have to solve it. So we're going to say, let's see here. So let C equal ounces of chocolate chips. Let P equal ounces of peanut butter chips. Oh, peanut butter, my favorite food. Peanut butter chips. Okay, so if C is the ounces of chocolate chips and P is the ounces of peanut butter chips, and we used a total of 16 ounces, that means C plus P is going to have to equal the total number of ounces of chocolate and peanut butter chips we used in our recipe. We know that there are 8 chocolate chips per every ounce of chocolate chips we use, and that there are 12 peanut butter chips for every ounce of peanut butter chips we use. So that would give us the total amount of the chips we use. So we know that we use 300 chips, and we use 8 chips per ounce of chocolate and 12 chips per ounce of peanut butter. And so this expression would represent the total. And so here's the system right here. This is the system you'd use to find C and P. C the ounce of chocolate chips and P the ounces of peanut butter chips. Alright, 34. A large room has the dimensions shown below. A partition is to be installed so that 2 classes can use it. The area of the small classroom is 38x. Write the expression in terms of x to represent the area of the larger classroom. Okay, so let's see where they're getting 38x from. So here's the smaller room right here. So that side is 38. That length here is x. So this would be 38x. So we want to figure out how long is this area right here. Well, we know that the height hasn't changed. The height is still 38. So 38 times this width right here. Well, what is this width? Well, we know that the total length is 50. So this total length right here is 50, but we're only concerned about what length this part is. So the total length is 50, so then let's subtract this length right here, and we know that that length is x. So this expression right here would tell us what the area of this part is right here. Okay, 35 is what we've just been doing in this most recent unit. Here's a parabola. It's asking us to find the zeros. Here's a 0 right here. Here's a 0 right here. Express them as ordered pairs. So that 0 is negative 1, 2, 3, 4, 5, 6, negative 6, comma 0, or 1, 2, 3, 4, 4, comma 0. Alright, 2 equations are shown below. What is the coordinate of the point of intersection? So we need to solve this system. So if you recall, the way we solve a system is by either substitution or elimination. And we use elimination when all of our variables, all of our x's and our y's line up on top of each other, and our constants line up on top of each other. So we will use the elimination method here. Elimination. So now we need to figure out what is an appropriate strategy to get a good elimination here. So choose a variable to eliminate. I'm going to choose y. So what number would I need to have in front of this y so that when I add downward, the y's would cancel? Well, here's a positive 4y, so wouldn't it be nice to have a negative 4y right here so that when I add down, I'd get a cancellation? Yeah, that'd be fantastic. I would love that. There's nothing I would like more than to be able to cancel those y's out. Let me get a zoom in here. Okay. So let's go ahead and do that. What I need to do to get a negative 4 in front of there, I need to multiply this whole thing by 4, that whole expression by 4. And so the 4 would multiply to all 3 elements of that equation. So I'm going to take it over here. That would be 8x minus 4y equals 8. And we'll just rewrite that second equation, 3x plus 4y equals 25. So we can see when we add down, those 4's are going to fall out of solution because those would cancel. So let's add down. So that'd be 11x equals 33, x equals 3. So we know the first value in our ordered pair is going to be 3. So now let's solve for that y. Well, what we can do is we can take that x and we can dump it into our original equation up here. So I'll rewrite it, making the substitution. So 2 times x, which is 3, minus y equals 2. Remember, this is our original equation, 2x minus y equals 2. So it's 6 minus y equals 2. Negative y equals negative 4. Y equals 4. There you go. So there's our work right there, and there's our finished ordered pair. Write an equation representing the area of the triangle. Well, we know the area of a triangle is 1/2 base times height. Here's our base. Here's our height. So let's represent that area. So area would equal 1/2 times the base, which is x minus b, times the height, which is x plus b. There you go. That would be a good equation representing the area. Find the solution set to the quadratic equation. 3x squared plus 19x equals 14. Okay, well, what we want to do is we always want to have our quadratic equations in the form of ax squared plus bx plus c equals 0. So we notice over here that our equation equals 14. So let's subtract 14 from each side. So when we do that, that equals 0. So we now have 0 equals 3x squared. Now, is 19x and 14, are they like terms? Can we subtract them? We can't because there's no variable after 14. So we need to add 19x minus 14 like that. And what we're going to do is let's use the quadratic equation to solve for this. So negative b plus or minus square root b squared minus 4ac, all of that is over 2a. So negative b, that'd be negative 19 plus or minus square root of b squared. That's nice, b squared. Let's figure out 19 times 19. Oops, 81, 9, 17, 9, 1. So that'd be 1, 6, 3. 19 times 19, is that 361? Yep, 361. So 361 minus 4 times a, well, that'd be 12, times c. Wait, let's see here. So a is 3. 3 times c is